Video. Weird.
Sound.
No, I don't need sound. I just want to test the video.
Are you gonna walk around?
Probably not.
Probably not. Okay.
Yeah, probably not. It's pretty clear, right?
Yeah.
It's weird. You haven't talked about this. The videos get all pixelated when you play it. It's very strange. I've never had that failure mode before. Not a failure mode.
Okay, so if you're set up, then I'll just. Oh wait, no, not. Yeah, just I don't know why.
You know, I don't know how to feel about this. I kind of like hate it, but I love it.
Okay, you got one
Okay, so let's get started. Just as a reminder, so we reserved just the first few minutes before talk for updates and kind of paper descriptions so that everyone knows what other people are working on. So first, again, we have the whole tentative schedule for the rest of the seminars. For the rest of the semester up on the MISC website. We have some really exciting speakers this week included, so I would check that out. Next week is Jessica Hallman, who will be presenting work titled Supporting Reasoning About Uncertainty with Data Visualization. Jessica Hallman is a professor at Northwestern University. She graduated from the PhD program here at the University of Michigan as well, so that'll be a return for her. So again, that's next week, same time. And just as a few updates on what people are working on. Actually, first, any other announcements that aren't in this document already? Yeah, got it. Sorry.
A couple months ago, I announced that we'd have a visitor, and she's down here. This is Ina Marie. She just arrived from Norway and will be working in my lab for the rest of the semester. So please help me welcome her to Ann Arbor. Show her. Welcome. And this is through the program. Did you see Barb? That's Barb. So Barb is on the board.
I could, yeah.
Of this international exchange.
Right, if people are interested in going to Norway, let me know.
What was it called again?
Okay, shoot, what does it stand for?
IPIT.
International.
Ask us. We'll tell you more about it.
Well, welcome. Okay, so let's just do one paper. So again, if you have more papers that aren't on here already, then go to this URL, bit.ly/miscannounce, and you should be able to just add a title, authors, a really short description. So let me just do one paper that hasn't been covered yet. Okay, let's do this one. Impulse Buying Design Practices and Consumer Needs by Carol Moser, Sarita, and Paul. So we investigate the features that e-commerce sites use to encourage impulse buying. So study one was a systematic content analysis of 200 top e-commerce websites and what tools consumers desire to curb their online spending. And they did a second study, which was an online survey of online impulse buyers with 151 participants in that study as well. Great, so yeah, and again, that's going to be presented at this upcoming Chi in May, in just one short month. Okay, so I have 3 minutes, so I'll leave it there. And let me project your laptop. Okay. So this week it's my pleasure to introduce Philip Guo. Philip Guo is an assistant professor of cognitive science at the University of California at San Diego. So the other CS, but you also have an appointment in computer science.
The real CS.
Well, yeah. He also has degrees from MIT and Stanford in computer science. While he was he wrote about his PhD experience at Stanford as well in an ebook called The PhD Grind. He's also written Python Tutor. So for everyone here, if you've ever taken 106 or seen 106, we use Python Tutor pretty extensively. Python Tutor has also been used by millions of students to help them understand how their Python code executes. Let's see. Philip Guo also has best papers at CHI, UIST, ICSI, the top conferences in his field. And he's also been awarded an NSF Career Award, I believe, this year as well. And he's also an effective communicator of what he does. So in addition to writing the PhD Grind ebook, he also hosts a vlog and podcast. So everyone, please welcome Philip Guo.
Awesome, thank you so much for the intro, Steve. It's really awesome to be here the past 2 days. I hope my voice hasn't worn out. My voice is worn out, it's actually a good thing. It means I'm really excited. Been really having really exciting conversations with many of y'all, and more meetings this afternoon as well. Looking forward to. So today I wanted to share kind of a broad swath of my group's work on learning programming at scale. This is my friend Kevin here. He is an oceanographer and research engineer. So this is the image he wants to portray of himself. Right, he's out on the ocean. These are underwater autonomous vehicles. They're basically underwater robots. He controls these robots, he writes software for them, and they collect all this data out on the ocean, right? But privately, he tells me that he basically spends 95% or more of his time like this, right? Hunched over in front of the computer, bad posture, in front of MATLAB, Python, basically building custom software for these robots and analyzing data from them. And I think Kevin is very emblematic of what modern day programmers are, right? And most modern day programmers, I would argue, are self-directed adult learners, right? That there's many people, obviously, who are majoring in computer science in schools, but thinking about an entire career, programming and computation has pervaded so many fields that they really need to be self-directed and learn oftentimes on their own throughout their career. So whether these are scientists and engineers, whether these are information scientists or librarians, this is a workshop I helped lead to teach data science skills essentially to librarians at Harvard. This was many years ago. Whether they're hobbyists, so they're makers doing ubiquitous computing devices, kind of connecting these devices together to make new interactions, or whether they're just more traditional software engineers who constantly have to keep up to date by attending industry conferences, watching talks, maybe taking online courses to constantly keep up with the rapid pace of innovation in the field. And if I had to summarize my research in one tweet, I would say it would be the following. So I studied how self-directed adults learn programming and build scalable learning tools. So roughly, I would say, if you look at the papers that my students have done over the past 5 years or so, roughly half are studies, right? These are studies about different and interesting self-directed adult learner populations and how they're learning a code and what their relationship is with programming in their work. And the other half is about building systems, especially at scale, for supporting this sort of self-directed learning. So let's go back to Kevin. So what did Kevin have to learn? Right, so when you think about learning programming, you might have learned some basic algorithms. You might learn software engineering, design patterns. You might also learn specific things about languages, right? So Effective C++ is a classic book, but nowadays kind of a lot of people are learning from the web. But you're thinking about learning the basics of code and algorithms. And the overarching message behind this talk this hour is that learning programming is not just about learning the code, right? Oftentimes people kind of conflate the two, but I want to kind of argue that learning programming is about something much broader. So here's what Kevin really had to learn. So he had to first learn to code, right? He had to learn programming language like C++ or Python, do data analysis, JavaScript increasingly, right? Building any kind of front-end user interface, oftentimes in JavaScript. Perhaps some of these web frameworks to help compose his applications. And then below just the code, you have to learn libraries like NumPy or Pandas to do data analysis work, something like TensorFlow to do machine learning now. Databases, you have to learn to interface with databases, things like MySQL. APIs, so you have now many modern day APIs are JSON-based, understanding data interchange formats, web APIs, how to feed data from different sources. Data visualization, V3, Vega, this whole ecosystem of ways to visualize your data as well. Then there are domain-specific tools. So this is a platform, this is an open source platform for connecting to these underwater robots that he uses. So kind of domain-specific libraries and platforms you have to learn. Specific tools like Jupyter Notebooks, package management systems like pip for Python or NPM for JavaScript in order to integrate and use this, the wide trove of libraries available. Things like Webpack, kind of build tools and configuration tools to kind of put together applications. Complex IDEs that tie together these tools into workflows. Operating systems, right? Understanding kind of the basics of a Unix-style operating system, what file systems are, what distributed systems are, how to run stuff effectively, how to write scripts. Version control and how that integrates into your workflow. And then now increasingly things are running more in the cloud, right? Cloud services, things like Docker and Kubernetes to have things all integrate together. And if this slide is an example of terrible slide design, that's exactly the point, right? Like this is just one example of many, right? You can imagine plastered on more and more of these technologies that people have to learn in order to actually be effective in doing anything in the real world programming nowadays in 2019. So I would say that learning programming is really about learning the code, right, at the most basic level, then learning about how to work with data, and finally learning how to work with environments. So both the software environment and increasingly hardware and cloud environments as well. So the purpose of today's talk is to kind of give a kind of overview of some of the projects that my group has been doing along these three fronts. So I want to talk about one representative project along code data environment. So in the code front, I'm going to present this Python Tutor project that I've been running over the past almost a decade or so that lets strangers help you code. And data front, this is a project my PhD student from the University of Rochester, where I used to work. This is my senior student. It's a project that allows you to co-opt the web for learning and playing with data science. And third web environment is a project about helping experts see through their blind spots in creating and curating tutorials. And this was done by one of my recent master's graduates at UCSD. Okay, let's start with the Python Tutor. So school computer labs are amazing, magical places. This is the computer lab at MIT from when I was a first year student working as a lab assistant for one of our intro classes. It was a very formative experience for me. So those of you who have taught or TA'd these sorts of lab-based programming classes, you kind of have memories of these labs as being very, very magical places where people get to interact. TAs get to walk around, students get to help each other. They're fascinating places just to kind of hang out in. But the problem is that adult learners are on their own, right? Like if you're someone like Kevin or someone who's kind of learning on their own online, there's nobody around. There's not that kind of physical lab environment to foster this sort of serendipity and pure learning. So even something as basic as here's a snippet of Python code, with some lists and pointers and stuff. Like nobody's around to clarify and explain to them what's going on here, right? You can maybe run it in a REPL or run in a thing and you see some output and try to debug, and it's not at all clear. This code is so opaque. So the system that I've been working on since I was a grad student was this Python tutor system, which is it's online at pythontutor.com. You can go play with it right now if you want. It actually works for a bunch of languages. It started with Python. I never bothered to change the domain. But what you can do is you basically write code in a variety of languages that people often teach in. It's just like an online code editor. This is the example from the previous slide. You run the code, and it runs on the server. It generates a whole execution trace, and then that allows you to see a visual representation, step by step, of how the code runs. And you can go backwards as well, to kind of see step by step what happens. Because everything just runs on the server, produces a full execution trace, and it allows you to basically visually debug and step through your code. And this works. There's many hours of engineering effort kind of to get this into a state where it basically could take whatever code you throw at it in 7 popular languages now. Here's the Java front end or back end. And basically all the front ends look the same. It basically looks like a visual debugger. So there's a program counter, control flow, there are these stack frames that grow down by convention. There are data structures, so we have a very simple rendering algorithm that renders link structures or arrays or tables and such. And the overarching design is trying to emulate what would an instructor draw by hand, right? So in a whiteboard or a blackboard setting, drawing these frames of dots and pointers and erasing pointers and moving it back and forth. Basically want to do all that in a as automated manner as possible. So the way to think about this is really for, you know, relatively small pieces of self-contained code you would see in a classroom or a tutorial setting. This is not for like throwing all the Linux kernel in it or something. So due to a lot of engineering effort and the kind of good timing with a lot of these MOOCs and online learning resources coming up, it's got quite a bit of usage over the past almost decade or so. So just from IP addresses and such, we got, you know, millions of users. From the thing I'm really excited about is not just numbers; it's just kind of the diversity of geographical locations that people are coming from. I think this was really cool, just kind of mapping that over time. You know, still the majority is, you know, U.S. and Western Europe and China and India. I mean, obviously we want to get into more places around the world, but it's a pretty good start. And many are self-directed adult learners. That's also what I find exciting, how I got really interested in adults. But we put up these user surveys, and most are over 25 years old. Right? So most people are not the ones who are using it in, you know, the 18 to 22-year-old group who are college students. And I think a lot of this is driven by MOOCs, right? A lot of this is driven by MOOCs and online learning resources and self-directed learning over the past decade. Okay, so this was this is something that has been up. It's been serving a lot of users worldwide. It's it's providing a lot of value, but we still don't have any interaction. Right? There's no person-to-person interaction. This is still kind of a tool you use by yourself, and it helps you illuminate some things, but still no one's explaining anything to you. Right? And what really makes the computer labs magical is student interactions. Right? You have students spontaneously getting together to work stuff out on paper or pair a program, or TAs or other students who are, you know, more farther along, walking around and helping out. And it's this very organic atmosphere where everyone has this shared context. Is you're all here to do this work for your class or whatever, and people are usually not messing around and stuff because you're all here with a shared context and you're here for a reason. And there's usually some kind of help queue, right? You put your name or often your computer number back when we had desktops on the queue and kind of ask what you want to ask, and then TAs or other students might go around and kind of work off the queue. But once again, adult learners are on their own, right? They don't really have this sort of interaction if you're learning by yourself or you're searching online on Google or Stack Overflow. So the question here is, can Python Tutor act like a virtual lab? And I wanted to do this for many, many years, but it kind of, it entered the realm of possibility around probably a year or so ago when the usage started, when the usage got up high enough that there were a fair number of concurrent users on the site. So this is the number of concurrent users who are visiting the site at any one time. And it usually varies around, a few dozen to up to 100 or so. And the cool thing here is it's 24 hours, right? So this is central time. So, it peaks daytime in the US, which is not surprising. But, even in the middle of the night in the US, we still get a lot of users because it has a very international user base. So it just means that anytime you're going on the site, chances are there are going to be a few dozen people on the site. And, I was wondering, can we nudge them to help each other somehow? So this is the live help mode. So on the left, I'm going to type in the exact same code as before, and the right, imagine this is someone like halfway around the world somewhere. Okay, so you can write code, same code before, and there's a get help button on the upper left. So you click that button, you add yourself to a queue. Actually play the high-res video. This video is a little lower resolution. I'm going to play the high-res video right now. So, wow, do not install updates. All right, so, whoa, this is getting weird. Ah. Should we re-plug this in? Let me see. All right, I'm just going to plug it back out of it. Yeah, video is always sad. Should we just redo the source?
Sure.
I know, I just broke the projector. Oh, here we go. Oh, that's
No,
that's
yeah. It's really strange.
That's really weird. Well, it's hard to do without the videos. Ow. Let's see. guess I'll reboot. Let me just reboot on my end.
In the worst case, we could also use
Yeah.
PowerPoint to present from this.
Yeah, I have a USB stick also.
Okay.
Well, we'll reboot. But basically what happens, I'll try to do charades. Basically what happens is there's a queue on top of the screen, and it's fairly unintrusive. It's basically like a queue of whoever's asking for help. And when you click the Get Live Help button, you just put yourself on that queue. And it's pretty unobtrusive, right? Like if people don't want to see it, they can just hide it. But if people feel like, oh, I want to jump in and help someone, they can just click a button, and then they join like essentially a pair programming session. So you can write code together. It's like Google Docs. You just write code together, and then you also see each other's mouse cursors, and then you also have a little text chat in line. So it's like you're pair programming in front of the same computer, except you're remote. And any number of people can join in if you want. You can also close the door. So like if someone is coming in and you're having a good conversation, you can just take yourself off the queue essentially, so that you don't have to, so that no one else can jump in. And we have, it's a fairly lightweight sort of interface in that we don't have accounts, we don't have any kind of persistence. Like we basically want to lower the barrier as much as possible. Everyone just gets a pseudonym if you just are on the site just based on your IP address and other kind of browser info. So you kind of know that that person is on, but we don't have any kind of personal information and such. And it's all, it's all anonymous, so like people don't know who each other is because presumably these are strangers anyways. And this actually ends up, I think the computer is updating. That's really weird. All right, I will, we'll just put PowerPoint on here. While it's updating, I think it might be vanished. Another pro tip is you should always have a USB stick in your wallet. I actually have two in my wallet, so always ready with a USB stick.
Okay, so I'll put that.
Oh no, I think it forced the OS update. Wow, that's good to talk.
Oh my God.
Amazing. I definitely said no up to upgrade, right? And then it just total dark UX pattern by Apple.
The real pro tip is to not just have the USB stick, but to actually have your talk on the USB.
That's right, that's right. Oh, or to have a virtual machine with PowerPoint, with the right version of it. Yeah, my talk is on the USB stick, it's just V5, yeah. Now let's see how this goes. Awesome, thanks Steve. Now we'll see Windows and Mac. We'll see the Windows and Mac differences.
Here, I'll just
Oh no.
keyboard.
Can I cancel or repair? Let's try to cancel. Where's the mouse? That's amazing. Okay, we'll try to repair. I've never done this on Windows before, so. All right, can you try to get this on Windows? I will try to. Oh, I think my computer's backed up, maybe. So okay, let's give one more try to plug in the computer in and then see what happens. Wow. Okay, my computer's back up, so let's just go for it.
We can also try this dongle.
Yeah. All right, let's try to go for this.
It's working now.
So, yeah, okay. Maybe we'll just keep it on that screen. Okay, let's quickly, I'll show the video, and then we'll breeze through some of the other slides as well. Okay, so basically what happens here is you can, right, you're typing code, you're doing Get Live Help on the upper left, and then that puts you on the queue. So I'm in Del Mar, California, right here. That's me. So now anybody else on the site, they don't have to know me, they don't have to log in or anything. They're just on the site working. And then there's a queue on the top. These are actually real people. I mean, this is me recording a demo. These are real people. I don't know who they are. That's me right there. So when you click to help, then you join a live session and you can chat with each other right there. So it's just a text chat, and and then you can do the collaborative coding as well.
Do they have context about what you need help with?
Yeah, that's a great question. Answer is no. Answer is this is like chat roulette. You just jump in and hope nothing bad happens. And then you can also, write code together and such. Okay, let me jump to this. Now, I'm afraid that when we switch modes here, it's going to be funny. So I'll talk about that right now, assuming the slide opens. Right, so basically here, let's hope this goes. All right. So basically, there's no accounts, there's persistent pseudonyms. There is no user-written notes to answer your question. The reason why is if you let people write a note that anyone on the site can see, someone's going to write something bad. All right. So because it's the internet, so we give location to give a sense of some personalization and the language they want help with, right? So basically, you're just kind of jumping in. It's basically a standard queue, but if you're idle, it just kind of demotes you. Just to, people get annoyed if they join in and no one's actually home. We basically we just rely on self-moderation. So whoever is starting the session, you can kick anybody out you want. You can also close the door, probably change this to be a little shorter. You can basically, so if there's disruption, if something's bad happening, you can kick them out and that bans them, and then you can undo their changes. And in general, just looking through the logs, there's not much in terms of off-topic or bad behavior, because if you're on the site anyways, you are probably like the students in the lab, right? You're not going on here to spam or anything, because it's not like, there's nothing persistent, right? It's all private. So we haven't had that much problem with spamming and such. So, the really cool thing here that I really love is how it really just connected people from all over the world. And so far we have about 13,000 recorded, pretty substantive sessions, which are very ripe for conversation analysis. And over 4,000 span multiple countries. So this line connects two locations if they span multiple. A lot of lines are within the same country, so it'll make it look really spaghetti-like. But I love how these are just people from different countries, just because they happen to be online. Most people are talking English, granted. There are people who speak write in other languages as well, but it's primarily English. So the first question I might be asking is, why do people actually do this, right? Like, why do people bother to do this? So we put up a little mini survey embedded in optional survey. A lot of it is learners taking breaks, right? They're taking breaks or they're seeking social interaction, right? So it's very much like this computer lab setting. It's like, let's see what other people are up to. I'm kind of curious. And maybe I can help, maybe I can't. It's all very low bar. Another one I love is paying it forward, right? So almost a third of the sessions had helpers who had previously asked for help. And many of the qualitative responses were that, I'm trying this because someone actually helped me on the site. Wow, this is amazing. I got help for free. This is kind of cool. I want to pay it forward and maybe I'll actually learn something. And then there were a minority of experts on the site too. So, there are teachers, people, the Stack Overflow crowd of people who are just kind of bored at work and wanting to answer questions, or people who are, retired programmers, maybe out of work programmers. So this was a smaller population, people who actually kind of go on the site. Yeah, Paul?
Did people say that they deliberately looked for people in certain countries? Or
that's a great, yes.
country?
Yes, there were quite a few that, this person's also from India and I'm from India. Yeah, there are a few.
Oh, I was going to guess it was the opposite. They were like, I can connect to somebody, I can have a pen pal from a new country.
That's interesting. I don't think I saw any of that. I saw some where like, I'm from this country too. Maybe they talk in Chinese or something. But yeah, I don't think I heard any that were explicitly for another country. That may be implicitly a reason. So from looking at the chat logs, we haven't done a super detailed analysis, but a preliminary analysis. A big recurring theme was the fact that these visualizations scaffolded the conversations, right? So the idea that having a visualization here, showing these data structures step by step, is deleting a pointer, reassigning a pointer. A lot of these operations in programming are these sorts of data structures and pointers and these sorts of operations that are fairly obscure. If you just stare at the code, it's not really clear what's going on. But by basically surfacing these visualizations and giving something people talk about, they can have these conversations like, reference to deleted object stays another reference, a new reference. So these are actually pretty complex thoughts that would be, I would say, impossible to have if you just had much harder to have a piece of code. So the idea that they're talking and referring to these visualizations, this has always happened again and again. So kind of going a little deeper on the conversational analysis, you think about Bloom's taxonomy, kind of those layers of sophistication of knowledge transfer. When we coded some of these results, we mostly saw things at the bottom three levels. So remembering is much more rote things like just syntax kind of errors and forgetting a parentheses or semicolon. And these things seem kind of trivial, but they really are blockers for a lot of beginners. So like even having someone just tell you, you need a semicolon there, it does get someone unblocked. At the understanding level, I think this has to do with language semantics, like the example we saw before, how pointers work, how aliasing work, and such. And there was some at the third level of Bloom's taxonomy application of, now that this thing is working, let's try another thing, or can we do a related problem and such. But we didn't really see anything that's more sophisticated, which is not surprising because these are fairly low-level, novice-level interactions. But still, people are getting these for free and at scale. But beyond the cognitive, I think the affective, the emotional sorts of interactions were really I think they're interesting as well. I think this is where this chat has, I feel like, an advantage over, say, Stack Overflow or discussion forums, is that there's a lot of these off-task conversations and side chats people had, right? So there was camaraderie, there was this sense of shared struggle, like, oh, I'm also trying to learn this from this other MOOC, and now this is really hard and such. Very much like a lab. Encouragement, also enrichment. People sent external links. People sometimes talk about career advice, like, oh, why are you doing this master's program or online program instead of, oh, looking for jobs, where are you applying for jobs? A lot of this sort of effective, non-cognitive stuff. So in examples here, learner said, oh my God, I'm terrible, I'm sorry, and then tutor says, not a problem at all, you've written little code, take you a while to be comfortable. So there's a lot of these kind of spontaneous things that, you would never see this on Stack Overflow, because Stack Overflow, the rules are you have to stay on topic, you can't be a human, you have to be an android on Stack Overflow. So I think this sort of, so the reflection here is that having this authentic and motivating context, having these real languages and tools and visualization that people would want to see, combined with the visual scaffolding is how you can start building up this this ad hoc community of people giving volunteer live help at scale. And this is just the beginning. You can imagine, for all the social computing folks out, you can just imagine all the possibilities that you can build into this sort of. This is kind of like the base version 0 of this. That actually, I'm encouraged that even version 0 with some light tuning and self-moderation actually works reasonably well. So like this is a direction I would love to keep growing. Okay, so I'm gonna keep going along since we lost a little bit of time on the projectors. Okay, so the second project, now for something totally different, DS.js. So let's go back to the example with code and data, right? So this is Kevin. This is kind of a usual data flow with somebody like him would do, hypothetically, right? So they're taking data from some device, right, some external environment. They're piping it into the device-specific platform, this library. This might be interfaced in the C++ interface. This might go to some machine learning model training thing to kind of collect data and train a model. That might feed into some API, right? You might expose this as an endpoint and an API in some clean form. That might get consumed by, say, Python to do some data analysis on it. It might also simultaneously get consumed by a front end that's like a dashboard or a kind of customization interface, and that might actually visualize some data somehow. So, code often interacts with real-world data, right? Whether it's device data or data from libraries, information services on the web, or data from wearable devices, or just if you're in any kind of company, this is user data, behavioral data, log data, and such. And I would say that programmers are now end-user data scientists. So the term end-user programmer or end-user programmer has a long history in HCI and software engineering. Kind of refers to people who are doing programming for personal goals rather than like to create something for mass use. And I think that now programmers are end-user data scientists. They're oftentimes needing to work with data and analyze data and play with data, not because their job title is data scientists. They're not data scientists, but in order to do any kind of real-world programming nowadays, you have to kind of understand the shape of data and how to work with it. So how do people currently learn these skills of data science? So people currently learn it by what they've always done for decades. They have an IDE or some kind of a programming environment. This is RStudio, but you can imagine MATLAB or a Python IDE or such like Jupyter Lab or Jupyter Notebook. And then they have data sources, right? They have CSV files they might download and import in there. They have a database connection. They might have these NoSQL databases or some web API they're scraping. But the idea is that they're shoving a bunch of data into a monolithic programming environment, and then they're working with it in that environment. So there are a bunch of frustrations that come with this for novices. First of all, it's just tool installation and configuration. You have to install these environments, install these libraries, install databases or hooks, or manage command line acrobatics with setting up a database, setting up data files and stuff. More fundamentally, the code and the data are completely disconnected, right? Data lives in one place on the file system or oftentimes remotely through some remote API, and the code lives kind of in one place inside your IDE or a version control system and stuff. They're completely separated. And the question we had thinking about this project is, can we reduce these frustrations by unifying code and data somehow? And we thought, what would be the best kind of test bed or playground for this stuff? And today it's the web, right? So the web is filled with structured data and semi-structured data of all forms. Wikipedia has maps, it has tables, it has lists. Any website you go to in any domain, government data, sports data, housing data, structured data and semi-structured data is just everywhere in the web. So this DS.js system lets you write data science code directly on any web page you visit. And here's roughly how it works. Let me see if the video resolution is good here. Let's see if this is. So basically, you go to any web page like Wikipedia, you click on this bookmarklet, and it inserts a code editor in line within any piece of data on your web page. So it preemptively parses CSV files and any kind of tabular data it can find, so there's a table, and it gives you a little code editor and also shows you a preview of the table it's parsed. It's called T7 here. I guess it's the 7th one on the page. And this is just a parse form of that table. Right? It's just in a data frame, data structure. So basically it parses these tables, also CSV files, and then it just lets you write code, right? So you can import any JavaScript library you want. I mean, there's this giant ecosystem of JavaScript libraries now for doing data science, visualization, increasingly some machine learning as well. And then you can just basically program right on the page because it's all just JavaScript. In effect, for those of you who use computational notebooks, it turns any existing web page into a notebook, right? So, if you're using something like Jupyter Observable notebooks, you have to, again, bring data into the notebook and import it in and play with it. But now, any web page with anything on it, it just, you turn, every data table basically is augmented with a notebook by itself. So you can, if there's a bunch of tables on there, you can just have a bunch of cells and you can play with it. So beyond just providing a basic program environment, there's a data API with some visual scaffolding. So this is going to be similar to Python Tutor. So the idea here is that if you use our API, which is very much like Pandas or the tidyverse in R, very basic API for data manipulation and visualization, then what you can do is, let's see, click on this. Oh. Then what you can do, play, Wow, the button for playing is right over the button for back. Okay, let's go here. Oh no, it happened again. It happened again, okay. Do you have to reboot again? That would be really weird. Huh. Can we go back to the room PC and switch back?
Yeah, it wasn't working when we tried to do repair either.
Yeah, I would just reboot. Okay, well, we'll have to go without video for the rest of it.
Can we copy the presentation over on this USB drive again?
Oh, to recopy it?
Maybe, in case, this is the,
Yeah. Can we switch to the laptop again just to see?
Yeah.
Wow, that's really strange. Okay, I just have to reboot the machine again. That is really strange. It's never happened twice. Okay, well, I'll know not to switch out of the presentation. I think we're good. I just have one more thing to cover, so
okay.
We're good. Okay, so basically what happens is there's basically, imagine the Python tutor, but for data science, right? So imagine the previews now are, instead of box and pointer diagrams of the sort that you would have for CS1 for an intro course, the diagrams are now about tabular data, about tables and slicing. So as you're previewing, as you're mousing over the code, the pieces of your data science code you're writing, you can see a preview of what may be going on incrementally each step. And it's really important because a lot of the data science code is great. If you're used to using things like the tidyverse or Pandas or Python, it's very declarative, right? It looks almost SQL-like. You're doing a transform, and it's great. But then it sometimes looks like magic, right? Because in one line of code, you get from this to this. It's like if people saw the draw an owl picture, right? Start with a circle and then you draw the owl in the end. It's like that, right? So it's nice to be able to go break it down. A lot of the novices wanted us to decompose these things into steps. So as you mouse over, you kind of see incrementally what's happening in data. And it works the other way around too, where as you can manipulate the data table directly. So as you mouse over parts of the data table, it'll tell you what parts of the API you can access. So this is very similar. If you've seen some of the data wrangler work that started at Stanford and turned into this data wrangling company Trifacta, it's very similar in that flavor. And the main difference is that we're using that to generate code that you can then fill in as a template. So it's not a drag and drop GUI. Okay, I will not exit out of the presentation again. Okay, I'm gonna speed over some of this stuff. Basically, there's Novice Friendly API here. All right, so this is one of the previews. Wow, amazing. Okay, so this is the other preview here.
Try spacebar.
Yeah, I think I tried before. So this is a preview of every sub-expression. You can actually see what's going on. It's selecting these selective columns, and a group by basically smushes and rotates stuff together into that. And we have some other previews as well you can see in the paper. The key here, the key hack here is that we're using the web pages themselves to host the data, right? So there's no servers, there's nothing you actually need to do beyond just, playing with web pages. And of course, we're assuming the underlying pages don't change, right? That if the underlying pages change, then yeah, your code can rerun, I guess, on new data. And the key is that we generate this garbled URL that consists of the web page URL and then your custom code. And then you can actually just give that to anybody who has this extension bookmarklet installed, and they can start playing with your stuff as well. So the reflection here is that we want to use the system to start exploring how do you turn the whole web into this authentic and motivating content for learning data science. I think this opens up a lot of possibilities because we really remove a lot of this installation and configuration overhead and feeling like your data is siloed from your code. And also, I think the context is really key too, because now, a lot of folks have been talking about teaching data science. A big thing that people want is how do we let people play with data in the context that they're motivated by. If you really like sports, you're on a sports page and you have all these athletes and you have data about them, you can actually start augmenting that with graphs or aggregates or other stuff. So when you present this in your class or something, it's kind of like you have a notebook on the real page itself instead of like, I download something and then you have to install something and here's like a picture somewhere. Okay, so final system called Porta is let's go back to our world of code. So if you think about yourself learning programming or teaching someone programming, this is what mostly is taught in a formal class, right? You're teaching semantics of programming languages and maybe some kind of libraries if you're doing web development or HCI. But this is a thing I go on a rant about all the time. So you can become you can read the entire C++ spec. I don't know how many of you have done so. It's 1,500 pages. You can be the world's foremost expert in C++ or Python or Haskell, whatever, but you still can't do anything in 2019 because you hit this cliff. And what the cliff is that there is an environment underneath your code that is increasingly complicated and convoluted and heterogeneous. And this is a tweet just from yesterday. So if y'all are tweeting on Twitter, it might make it into my talk, so be careful. This is from my friend Gene. It says, the version situation has gotten so bad that even when I'm not coding in Python, but simply using stuff packaged with scripts written in Python, I'm spending non-trivial time system adminning, doing system administration work, just to do basic things. So for those of you who don't know Jane, Gene is now, she's a startup founder now, doing data security startup, very much a data science data security startup. Previously, she was a professor at CMU in programming languages, and for her PhD work and for a bunch of work, she made domain-specific languages in Python. So and someone like her is not able to even get stuff working. I don't know if there's any hope for the rest of us. And this is a perfectly timed tweet because programmers are end-user system administrators. Now, like it or not, if you want to do anything non-trivial programming, you have to kind of turn into understanding system administration somehow. What is all this stuff, right? And anything beyond, again, your CS1 course, the students are going to start running into this barrier, this cliff, I call it. So how do people currently deal with this? They basically read tutorials online, right? There's all sorts of tutorials, Docker for Amazon stuff, TensorFlow with pip, Webpack Visual Studio, Webpack ES 2015. Basically every combination of terms has some tutorial that goes along with it that is probably outdated somehow, right? So these tutorials are really hard to make, right? Giving credit to the creators. They have this really uphill battle because the learners' environments are probably different than their environments, right? They're writing a tutorial and they're on their computer and they're testing it and stuff. And who knows what kinds of machine configurations are laptops getting force installed with the latest Mac OS or whatever that breaks stuff. It's just really hard to get these tutorials working. Another one is obsoleted by library updates, tool updates, OS updates, right? If you make a tutorial for anything that's environment dependent, something is going to update in a few months, and then some part of the tutorial is going to be broken. And even if you get everything perfect, there's an expert blind spot problem, right? That this is the kind of concept that if you're an expert, you probably are skipping critical details, the drawing the owl cartoon again, right? That you're like, oh, go from point A to point B, that seems easy, but then novices probably need you to fill in more blanks in between. So the worst part here is that the creators can't see what's going wrong, right? They're throwing these tutorials over the wall. Maybe people might email them or send them a forum post and stuff, but they can't really see where people are following these tutorials, what's tripping them up and such. And if you're an instructional designer or a course instructor, you'll probably see this all the time, right? You write this beautiful materials for your class, and then like next year when you want to reuse it, some little part in the middle is broken, and then you like have to go and fix everything again. So that was the motivation behind this project, is can we show creators where learners struggle when they're following these sorts of complex tutorials. So this Porta system my student built does two things. It records how learners are following a tutorial, basically tracing what they're doing on the tutorial web pages. And it also follows what else they're running on their computer. So here's an example. This is from some of our intro HCI class materials. The spacebar does not work. I wonder if there's another key. So a lot of tutorials look like this, right? You scroll down, there's a bunch of code, there's a bunch of demos, there's a bunch of, there might be some embedded videos on the side showing animations and such. And they're just basically structured, usually vertically scrolling web pages. So, so what Porta does is that when you install this, this extension for Mac, it records a screencast video of your tutorial following session, so your testing session. And it also records a bunch of metadata on your computer. So it first records metadata in the browser, such as mouse location. So we use mouse and scroll location as a very rough proxy for attention, right, because we don't have an eye tracker. So we're like, if you're hovering over this or copying this code, you're kind of paying attention to this part of the screen. The viewport's active. It records what browser tabs are active, if you're playing videos and where you're playing the videos. The JavaScript console, because like if you have a bunch of JavaScript errors, maybe you're doing web development, there's a bunch of errors on your console. Then it hooks into your compiler, interpreter, or tool chain. So like if you're running Python or Java or GCC and stuff, or Make or other build tools, it hooks into that tool chain so that whatever IDE you're using, it can tell you what code you're trying to compile and run, whether there are errors and everything. This is all away from your browser. Then we instrument your shell, so we know what command line commands you're running, which might include package management, installation, build scripts, and everything. So we collect all of this data together, basically a screencast video with all the metadata timestamped, and then we can actually make an interactive visualization. So the idea, this usage case is, imagine you have people testing your tutorial, whether these are students or your TAs or people you hire online. They install this extension, it records, maybe there's 4 people or more, and it creates an aggregate visualization, basically showing a heat map with a bunch of events that are faceted. And we call this a tutorial profiling visualization. And it's similar to code profiling, so if you're familiar with a code profiler, what that does is it shows you which points of your code have a lot of activity or have a lot of slowdown, so you can kind of focus your optimization efforts on those parts. So it's a similar analogy. It's like code profiling, but for everything you do on your computer. So let's, so if you scroll down here, you'll see that there's kind of a red heat map on the left side vertically. So this kind of shows, someone spent a lot of time here. Is that a good thing or a bad thing? I don't know, right? It could be good because they might be spending time. Then there's a bunch of these events that are marked, basically where they were, while they were here, something happened. And these events could include errors. It could include, files being created, files being modified. And when you click on one of these events, it will pop up a contextual detail that shows the video clip right around when that event occurred. So it kind of, instead of an hour video you're watching a 20-second clip of them reading this part, maybe copying code in, running something in their system, and like getting a command line error or something. You can also filter by event type. There's a bunch of event types we have, and facet by users as well. So this gives you kind of a bird's eye view of how a group of users might be going through your tutorial. So very quickly, with this user study, with 3 widely used tutorials, data science, web, and a GitHub tutorial, which is much longer. And these have been widely tested in classes and MOOCs and everything. And we had access to their creators as well. So we had 4 students follow each one. And then each student gave feedback before seeing the visualization, just in general, what feedback do you have, what bugs did you notice? And then while playing with the interactive visualizations. And then each creator reflect on their own tutorial, again, before seeing the visualizations and while playing with it. And the upshot from all of this is that exploring these visualizations really help people give really specific and very actionable and detailed feedback. So most of the students went from looks okay or vague comments like, oh, seems fine, to really, really specific critiques, right? It's not surprising since they had this tool to really help them drill down. So they really looked at where they were spending time or where their classmates were spending time, and then drilled down to the events like, oh, I think you should make a really specific change here. So, so it's like here, no explanation of where this event object for this click handler comes from, so maybe you should add an explanation in this part of your tutorial. And all three creators went from very high-level ideas, again, to very specific improvements. And the most surprising thing is that they all saw pretty surprising behavior that they never noticed, given that they had taught with these materials before. Right? They had taught several versions of classes of materials, and they still saw something. And it's some kind of an indication that they had this, that it helped them a bit overcome this expert blind spot. So these are kind of markers roughly where the students, the learners, said really specific feedback, and the right side is where the instructors found really specific points to improve in their own tutorials that was extremely targeted. So in the last 5 minutes or so, I wanted to kind of wrap up with a take-home message. So what these three systems that are in very, very different domains have in common is this theme of visual scaffolding or visualization. So Python Tutor visualizes the code execution details for kind of a CS1 intro level. DS.js visualizes the code and data linkages together. And Porta visualizes learner activity and errors. And the thing that we've learned from building all these systems, even though they're really different domains, is that these visualizations should really act as scaffold, but they shouldn't hide the grimy details of code and data. And this is, this point of view, I think, is complementary to a lot of tools in end user programming or in education, which try to use visualizations as the primary mechanism for hiding a lot of these details of code underneath to give people code-free environments in which to edit stuff. And I think those are really valuable for a lot of cases. But I think for people who aspire to be programmers and to build these sophisticated apps, I think it's really important not to hide that. And I think really the target population I'm targeting is that these self-directed adults, they want authentic tools situated in motivating context, right? They want to be able to do real stuff in their domain, whether it's in robotics or in information retrieval or in wearables. And they want to be learning in the context. They want that to matter to them. So that means that in the Python tutor system, they really appreciate the fact that these are real people who are helping them out in this context that they're motivated. For DS.js, the motivating context is the web itself, which is a very motivating source of data and context. And then for Porta, the motivating context is hopefully these are real tutorials in the wild that you can use and test off the shelf. Right? And so my last few minutes or so, I want to go back to the messy picture we started with. So kind of taking this in and thinking about the state of the world today in 2019. When you all extrapolate, what would this look like in 5 years' time? Right? Is this going to look really beautiful? We're going to have we're all going to be programming in Haskell and just just one language through everything. In 10 years, in 25 years, and what would this look like? And I think my somewhat pessimistic view of the future is that I think programming is going to keep getting more complex. It's going to involve more multilingual code, right? It already does. Or if you're thinking about building modern web or mobile applications, you're operating on different levels of abstraction with different specific languages for everything. It's going to grow more reliant on data, and it's going to be a more complex environment. So, we have a lot of work to understand how we program on desktop and laptop computers, and increasingly on mobile as well, right? There's a lot of work coming out about how do you build good interfaces for mobile. But thinking way beyond that, right? We have low-powered autonomous vehicles, we have smart homes. All of these devices can be programmable. I mean, now they already are, but they can be made, they can have hooks and APIs made more accessible so people can automate their homes, self-driving cars, all these sorts of autonomous devices. Even more scary, wearable devices, implantable devices, right? Like, we're going to be walking around with implantable devices that we can customize and program and grab data off of it and play with. And what would that mean for the future of programming? And I think because of that, programmers, right, will need to be more and more code polyglots, right? You're going to have to learn how to work with more than one language or paradigm. That's just, it already is the case, and I think it's going to be more the case because each of these environments are going to have their own programming stacks. They're going to have to be data scientists more and more, right? Because these, things are interacting with real-world data. And they're going to have to be system administrators, right? Because they're going to have to understand the underlying hardware and software environments that these all come from. And here's the paradox, right? Here's what kind of keeps me up at night, is that as coding becomes more accessible, more learners will face these barriers. So like, there's been a tremendous amount of efforts, which is awesome, especially over the past decade, with a broadening participation in programming and computer science, making, developing tools and curricula and initiatives to get more people into being empowered by programming and using computational tools. And that is awesome, right? Where we want more people in this field. And I think the paradox is that the better job we do at that, the more learners are going to run into this cliff, right? That like the better job we do at this, we have this promise of empowerment and of, we teach people you can make all these things, this is awesome, and you can, but they're going to hit this cliff, they're going to really hit this cliff. And I think that these learning tools, the next generation of learning tools that I'm really interested in developing, I would love to see the field move toward more, is if they have to take this complexity head on, right? That we have a lot of great things now about learning to code, and there's still just learning basic coding is a challenge, and there still needs to be a lot of work on it. But I think that in the coming decades, learning the code just won't be enough. It's really the tip of the iceberg. And that we really have to think about not only the code, but also really think about how things interact with data and with underlying software and increasingly hardware environments as well. And I view this talk really just as a way to kind of show the urgency and the increasing urgency of this problem. And these systems themselves, our group has other systems within, I kind of categorize our systems as either code, data, or environment. We have other systems in this domain as well. This is just kind of a preview of things, but really the message I want to get across in this talk is to think that just from a technical level at least, there's a lot more than just code. And then, we've had some really good discussions that this is just the technical end, right? The empowering people to do programming and to be computational thinkers and practitioners involves more than just the technical part, right? There's a whole orthogonal part about the psychological and the social, and which is super important as well. But I think even just along the technical realm, there's so much more to do. And with that, I want to thank my students who helped on many of these systems, and had many more students to acknowledge in the systems that I didn't get a time to present today. But I'm happy to talk to folks afterwards as well. It's 12:50, but I'm around all afternoon as well. So thank you so much.
We can do some questions. Of course, some people might have.
Okay, so I'm interested in how people were asking for help. So in the case of Python Tutor, did you observe or even study the differences between how novices from these different geographic locations were asking for help? Were there cultural differences in that?
Yeah, the answer is, I would love if we could work on that together. Yeah, the chat data, the data is all there, just we haven't had time to look at it. But clearly, the geographic thing is a great way to think about it. And beyond just their styles of communication, does it matter that someone from, kind of calls, you have someone from India is interfacing with someone from Northern Europe? Is that different than someone from India interfacing with someone from India, even though they're all speaking English? I think these sorts of cross-cultural interactions are fascinating to study, and we'll do more of that in the future, hopefully. Yes? Okay. Yeah, go ahead.
Thanks for your talk. This is great. I was just curious. I have a couple of questions. You mentioned that DS.js came from novices asking you for questions. Were you able to get a sense within Python Tutor what they needed in order to inform the design of DS?
Oh, no, it was completely separate.
Oh, okay.
Yeah, sorry, I didn't mean to.
So in what context were you saying learners kind of told you that they needed help
we did a formative study. So for DS.js, my student, we basically did a formative study. We talked to a bunch of, we mostly talked to the TAs in the courses about what friction points, a lot of the design points came from the TA's perspective. So that was more done in a traditional classroom setting, even though this tool could be used online as well. I think we have one back there, and then yeah.
Yeah, I was wondering on Python Tutor, if you've looked at, so I know a lot of them are adults doing potentially online courses. If you look at clusters and what the programs themselves are, so if there's certain programs that appear multiple times, or like certain ideas that people are trying to solve.
Yeah. There are folks, yourself and others, who are working on. Yeah, I mean, I've been working with folks to look at that data. I don't have any I guess the issue with that sort of exploration is I think you need a really